All right, welcome to section 14.5, the chain rule. Recall from 14.4 differential. Okay, we know that dz is equal to fx, right? Dx plus fy dy. Okay, so now we're just gonna do a little trick, right? We're gonna divide everything by dt. Okay, so divide by dt. So we have a dz over dt fx, right? Dx over dt fy dy over dt. Well, this is the same as taking the derivative with respect to t. You see, now, for some students, it is easier for them to see the tree diagram for the chain rule. So this is the chain rule right here. This one right here, we call it the chain rule. Well, easier way to see is gonna be using a tree diagram. We have a function f or z, yeah, it doesn't matter because f is the same as z. Well, the function f here has two variables, x, y. So when we take the derivative, we're gonna have to do the partial derivative, right? So partial f, partial x, that fx, right? Partial f, partial y, fy, and then x is the function of t, y is the function of t. So when x and y, they are function of one variable, the derivative is going to be a dx over dt, dy over dt. Yeah, so and then you get the same thing too. Assume R and H are function of time t. And the volume of the cylinder is V equal pi r square h. If r equal et and h is equal to e negative 2t, phi v prime t. Chain rule here. V prime t, right? According to the definition, it's going to be a VR dr over dt plus vh dh over dt. Yeah, if you know differential, then this thing is going to come in pretty fast though. Okay, partial derivative with respect to r. 2 pi r h, and then d over dt is gonna be et partial derivative with respect to h pi r square, and then derivative of h with respect to t is gonna be e negative 2t times negative 2. Okay. What do we have here? We have a 2 pi r h et minus 2 pi r square e negative 2t. Next step is that we're gonna have to do the sub, because it's a if r equal et and h equal e to the negative 2t, right? When I'm gonna do the sub here. Sub. Subdomain. Now see what we have. We have a 2 pi r is et, h is e negative 2t, et minus 2 pi e t square e negative 2t. Oh, what do we have? We have a 2 pi minus 2 pi. Everybody say that they are the same, right? Zero. You can always do the substitution before you begin to do the derivative, right? Method 2. Sub first before taking derivative. Yes, sometimes this way is faster though. Okay, so sub, right? So what v is equal to pi r square h, right? We're gonna do the sub here. So this the pi r et square h e negative 2t, and then as you can see, right, I have room to work it out. So e 2t e negative 2t. What do we have? We have a just pi, yeah? And then ta-da, what the heck? So v prime t is going to be 0. It's the derivative of pi, so this is 0. Let fxy equal x square minus 3y square plus 20. Where x equal to cosine t, y equal to sine t. Gonna do 210 here. Gonna find df over dt and evaluate it at t equal pi 4. And then we're gonna interpret the result geometrically. From part A, geometrically. But for the sake of the chain rule, I'm gonna work it out using the chain rule. Yeah. Okay. df over dt, right? From the chain rule is gonna be fx dx over dt, fy dy over dt. Yeah. Okay, so fx, that 2x dx over dt, yeah. And derivative of cosine is negative sine, so it's gonna be a negative 2 sine t. Fy negative 6 y. Derivative of sine is cosine, so 2 cosine t. What do we have? We have a negative 4x sine t minus 12y cosine t, and then you got to do the sub it in. Minus 4, x is the 2 cosine t, y is 2 sine t. Okay, almost done here. So it's negative 4, right? 2 sine t cosine t minus 12, 2 sine t cosine t. Right? So what do we have here? We have a negative 16, 2 sine t cosine t. And then 2 sine t cosine t is sine 2t. Yeah, it looks much better. Yeah? Sine 2t. Okay, so we have this one, and then we're gonna evaluate this at t equal power 4, right? So at pi 4, negative 16 sine 2 times pi 4. So this negative 16 sine of pi 2. Sine pi 2 is 1, so negative 16. Okay, so we have the answer here. Right. B is we're gonna interpret the answer here. Interpret. This one. Yeah, what does this mean? Right. We know fxy is a surface that and given x equal to cosine t, y equal to sine t. Well, which is a circle of radius 2 on the xy plane. So what's this mean? It means that we restrict the surface to be on this domain df over dt pi 4 equal negative 16 tell us that as we walk along the boundary of the surface, it's the boundary because the domain is just a circle of radius 2 on the xy plane, right? So you cannot have the entire surface. You're just gonna have the boundary of the surface fxy because of the restricted domain. Yeah, the domain is not everywhere. You got to be careful. The slope or the rate of change of the elevation with respect to time is the slope is negative at the point or coordinate t equal pi over 4. And you can actually get this coordinate here. How do you get it? When t equal pi over 4, you get x equal to 2 cosine pi over 4. And that gives us to be root 2 y 2 sine pi over 4. That gives us to be another root 2. Z is equal to, this is 0 here. X squared minus 3y squared plus 20. So that's going to be a root 2 square minus 3 times root 2 square plus 20. And that is 16. At the point root 2 16, you are walking downhill. Let t be C degrees Celsius temperature at point x, y. Across so that its position after t second is given by x equal root 1 plus t and y equal 1 plus 1 over 2 t. How fast is the temperature rising on the bulk path after a second? Why 8? Because the 8 look nice. Then you can do root of 1 plus 8. That is root 3. It gives you a nice number. How fast is the temperature rising on the bulk path? Well, it is asking for us to do dt over dt after a second. Yeah. It is what it asks us to do here. So you can do either way, right? You can either do the chain rule, or you can just do the substitution and then just take the derivative with respect to t. Up to you. I'm gonna do the chain rule here. Dt over d smaller t, derivative with respect to t. So it's gonna be a tx dx over dt plus ty dy over dt. So tx is gonna be y, dx over dt is gonna be a half of root 1 plus t. Ty is x, dy over dt, that's gonna be a 1 over 2. Right. So next step is that I'm going to sub in the x and the y, and I'm going to do the substitution here. 1 plus 1 over 2 t 1 over 2 root of 1 plus t x root 1 plus t times 1 over 2. Okay. So, okay. So now we can compute dt over dt of 8. 1 plus 1 over 2 times 8. 1 over 2 root 1 plus 8 plus root of 1 plus 8 times 1 over 2. Almost there. It's the 5, and then now what do we have here? We have a 1 over 2 times 3, so that's 6. 3 over 2. So 5 over 6 plus 3 over 2 is the 14 over 6. Actually, I want you to see the problem, so I'm going to write right here. 7 over 3 Celsius per second. 7 over 3. It looks like the bug is getting fried slowly. If you have the stomach to eat some of them, they taste pretty good. Especially if you have a chance to go to Thailand and you eat the spider. Right? They fry the spider. Spider tastes like chicken. Let W equal to ln square root x square plus y square plus z square, where x equals sine t, y equals cosine t, z equals tangent t. Phi dw over dt. And I'm gonna solve first, right? Because I know there's a little trigonometry identity here. If you know trig identity, it will save you. ln root of sine square plus cosine square plus tangent square. Yeah, okay, so now it's going to be ln, right? Sine square plus cosine square, it's going to be 1. Trig identity. So you're going to get a 1 plus tangent square t. Oh my God, look at this thing here. And then you're going to do ln 1 plus tangent square. Well, got to know a little trig identity. Trig identity. That would be square root. 1 plus tangent square, secant square. And ta-da! It looks like we're almost done here. It's the square root and the square, they're going to cancel each other out. So this is going to be a ln secant t. Okay. Let us just solve first, right? And then now I'm going to do a dw over dt. That is the derivative of ln secant t with respect to t, and this one is going to be a derivative of secant t is secant t tangent t over secant t. So the answer is tangent t.